Hello everyone, this is Zulaikat Faima of CSC Cybersecurity Department, pursuing my education in Sri Venkateswara College of Engineering, Bangalore. I am here to talk about the topic access control, understanding static in Java. So let's see about the introduction to access control and static in Java. Access control in Java refers to the process of limiting access to classes, methods, and variables. Static in Java is a keyword used to declare a static member which belongs to the class itself rather than an instance of the class. Understanding access control and static is crucial for writing secure and efficient Java code. Access modifiers. Java provides four access modifiers: public, protected, default, and private. Public access modifier allows unrestricted access to a class, method, or variable from any other class. Protected access modifier allows access within the same package or subclass in different packages. Default access modifier, also known as package private, allows access with the same package only. Private access modifier restrict access to the class itself, making it inaccessible from other class. Here we can see some of the examples of access modifiers in Java. Access control examples. Example 1, using public access modifier to allow access to a method from any class. Example 2, using protected access modifier to allow access within a package and subclasses. Example 3, using default access modifier to restrict access within a package. Static variables. Static variables are shared across all of instances of a class. They are declared using the static keyword and are initialized only once. Static variables can be accessed directly using the class name without creating an instance of the class. Static methods. Static methods belong to the class and not to any instance. They can be called directly using the class name without creating an instance of the class. Static method cannot access non-static or instance variables directly. Static blocks. Static blocks are used to initialize static variables or perform other initialization tasks. They are executed only once, when the class is first loaded. Static blocks are written inside the class but outside any of the methods. Static block is a block of code prefixed by static keyword. It gets executed only once. It is used to initialize static variables. Here we can see the example. Static blocks are executed in the order they appear in the code. Static blocks can also throw exceptions which need to be handled or declared. Static versus instance. Static variables and methods are shared across all instances of a class. Instant or non-static variables and methods belong to individual instances of a class. Static members are accessed using the class name, while instance members are accessed using an instance of a class. Benefits of static memory efficiency. Static variables and methods are loaded only once, reducing memory usage. Global access. Static members can be accessed from anywhere in the program. Easier code organization. Static members are defined at close level, making the code more organized. It means that all memory is allocated to each process or thread when the system starts up. In this case, you never have to ask for memory while a process is being executed. This is very costly. The advantage of this is embedded systems is that whole issue of memory related bugs due to leaks, failures and dangling pointers simply does not exist. Pitfalls of static. Thread safety. Static variables can cause issues in multi-threaded environments if not handled properly. Dependency on order. Static blocks are executed in order, which can cause issues if not properly managed. Difficulty in testing. Static methods can be challenging to test due to their global access and potential side effects. Static and inheritance. Static members are not inherited by subclasses. Subclasses can declare their own static member with same name, effectively hiding the parent static member. Static methods in subclasses cannot override static methods in the parent class. Static and polymorphism. Static methods are resolved at compile time based on the type of reference variable. Virtual method invocation, which allows dynamic binding, does not apply to static methods. Therefore, static methods do not participate in polymorphism. Polymorphism has two: compile time and runtime. Under compile time, function overholding and operator overholding. Under runtime, virtual functions. Best practices for access control and static. Use the most restrictive access modifier possible to ensure proper encapsulation. Avoid unnecessary use of static variables and methods as they can lead to code complexity and potential issues. Be cautious when using static blocks and ensure proper handling of exceptions. Summary. Access control in Java is used to limit access to classes, methods, and variables. Access modifiers such as public, protected, default, and private provide different levels of accessibility. Static in Java is used to declare static members that belong to the class itself and are shared across all instances. Static variables, methods, and blocks are loaded only once and can be accessed directly using the class name. Static members are not inherited by subclasses and do not participate in the polymorphism. Understanding access control and static is crucial for secure, efficient, and well organized Java code. So, here I end up my topic. Thank you.